We'll have a look at how we get an intercept with a planet, where we're looking for a direction of a position line and a position through which it passes. So we're given ship's time and the day, 17th of May, and our DR position, and with the sections altitude of Venus, with a chronometer reading. Now the first thing you have to do is establish what day is involved and an approximate universal or GMT. So we're at 6:30, or I'll just call this 6 o'clock on the 17th. Could have put 6:30 there. Our longitude in time approximately is 10 hours. So our approximate GMT will actually be the 16th at around 2000. So when we look at our chronometer, it reads 8:45. So we must obviously convert that to 20:45, and we must use in the tables the 16th of May 20:42:46 with the correction to the chronometer. So with that information we can now get our GHA of Venus and the declination. And you mustn't forget, with Venus there is a V correction, and on the page where you have Venus at the bottom you'll see a V correction mentioned, and of course the D correction is for declination. So we get both those values. Now they're not the values you apply, they're the values you use in the increments table to get the value to apply. So go to the increments at 42:46, look up 0.9, and you'll see that the value is 0.6. We add the declination because the declination is increasing. Again, if you look in the almanac, you have to see whether the declination is increasing or decreasing, and that will tell you whether you need to add or subtract. Then we can use our formula to get the calculated zenith distance. But notice our declination is north, our latitude is south. If they're named differently, as they are, we must use a minus sign in this formula. Had they been named the same, it would be plus, but they're named differently, so it's minus. So that's our CZD, calculated zenith distance, 6203.6. Then we can now calculate our true zenith distance, going through the sextant, index error, dip, apparent altitude, true altitude, 90 degrees, true zenith distance. Compare the two, and we can see that our intercept is 7.9 miles away. So that's how we get our intercept, and then we can use the ABC formulas or the tables to work out our azimuth. And I've got north 49.4 east, therefore our position line runs 139.4, 319.4. We can then work out the ITP position by using the formulas, and to work out our DLAT and departure. So DLAT, apply the DR lat, apply the DLAT to get the ITP lat, and then get the mean lat, carry that forward to get the D long, and therefore we can plot our ITP position, or in other words intercept terminal point. So that's how we would solve that problem. Of course you can always plot the ITP as well on radar plotting sheet, or calculate it as you've seen there.